topic we're going to talk about in this section is average rate of change of a function. So let me go ahead and read this definition. It's going to be really mathy, but after I read through it, I will talk about it. Okay, it says if A and B, where A and B are not equal, are in the domain of a function y equals f of x, the average rate of change of f from A to B is defined as f of B minus f of A all over B minus A. All right, so here's the definition that I have read to you. Okay, and you can see there's two other variations of the formula, which I will talk about as we go along. Okay, so first of all, let's try to make sense of this formula that I have boxed. Okay, so you're going to have some formula, the equation will be given, and then you keep seeing this A and B being mentioned. Okay, so what A and B are, these are x values. Okay, and keep in mind, they cannot be the same x value. They are different. They cannot equal. Okay, so what is going on? Let me draw it out. That might make more sense. Okay, so I'm going to start by drawing a y-axis, and then I'll put an x-axis on here. And I'm just going to draw some random function. Okay, so maybe it looks like this. Okay, so this is my function. All right, so like I said, okay, A and B are x values. Okay, the function that you're given, its domain could be all real numbers. It may be defined, everywhere, but you're only going to be interested in the portion of the function between x equals A and x equals B. Okay, so I'm going to put x equals A right here and x equals B right here. Okay, so you're only going to be interested in the portion of the function in between these two vertical dotted lines. Okay, so if you look at the formula in the box, let's start with the denominator because it's easier. Okay, the denominator is just B minus A. You're subtracting the x values. Okay, and then let's talk about the numerator. Okay, the numerator is f of B minus f of A. Okay, well, f of B, we know what that means. F of B is the y value when x equals B. Okay, if you go back to the picture, here's where x equals B. Just found the output on the graph. Okay, this point, this y value right here would be f of B. Okay, and then similarly, we know f of A is the y value when x equals A. Okay, so if we locate x equals A, go up to the graph and find the corresponding point. Okay, the y value here is going to be f of A. Okay, so f of A and f of B are y values. Okay, so we're subtracting y values in the numerator. Okay, so that's going to bring us to the second representation of this formula. Okay, you see that little triangle? It's the Greek letter delta, and what it means is change in. That's how you read it. Okay, so another way to think of average rate of change of a function, it's the change in y over the change in x. Okay, and the reason you can think of it that way is because in the numerator, you're subtracting your y values. So you're determining the change in y. And in the denominator, you're subtracting your x values. So you're computing the change in the x values. Okay, another way you can think of this formula is this last representation, y2 minus y1 over x2 minus x1. Okay, so let me explain that. All right, I'm going to go back to x equals A, and we're looking at this corresponding point on the curve. Okay, this red dot right here has coordinates. The x value is A and the y value is f of A. Okay, and then over here with the blue dot, the x value is B and the y coordinate is f of B. Okay, so really these are just two points on the curve, okay? We can rename them. A and f of a is kind of complicated, and b, f of b is kind of complicated. We can also call this red dot, we could name it x1, y1. Okay, let me rewrite that. All right, let me try that again. Okay, so x1, y1. Okay, so think of it as our first point. It's the leftmost point. It's the first point we encounter. So we'll call the x coordinate x1 and we'll call the y coordinate y1. We can do the same thing on the right side. Instead of b, f of b, we can simplify this. This is the second point we encounter or that we're interested in. So it is going to have, we'll call its x coordinate x2 and its y coordinate y2. Okay, so then if you just did the same kind of thing in the numerator, if you just subtracted the y coordinates, it would give you y2 minus y1. And in the denominator, if you subtracted the x coordinates, you would get x2 minus x1. Okay, so basically all you're doing here, okay, is you're going to have some function. Okay, you could graph it, you don't have to, but you're going to be interested in two x values, the portion of the function between these two x values. Okay, so basically you're going to take each x value and you're going to plug each one into the function to get the corresponding output. And from that, you're going to be able to write down an ordered pair from each x value. Okay, so like you'll plug in the first x value to get a y value, so that will produce x1, y1, and then you'll take the second x value, plug it into the function, get an output that's going to produce the ordered pair x2, y2, and then you just follow the formula, okay? y2 minus y1 over x2 minus x1, okay? That is my preferred way of thinking about it, but you can certainly, if you prefer f of b minus f of a all over b minus a, then go for that. Okay, now we have not talked about lines yet. That's coming up. That's the next section we do, but you may recognize this formula. Okay, this formula right here, this y2 minus y1 all over x2 minus x1. That's a very important formula in algebra. Okay, this is the formula for the slope of a line. Okay, so let me write that down. This is nothing more than the slope of a line. Okay, so what you need to take away from this, and we're about to do an example, average rate of change of a function, even if that function is not a line, average rate of change is nothing more than the slope of a line. Okay, so in the next example, we're going to compute an average rate of change, and then I'm going to graph it out and show you how to interpret it. Okay, it's a little bit confusing because the formula is basically computing the slope of a line, but the function you're dealing with may not be a line. Okay, so let's take a look.